Okay, hello class. We're again back. We are doing chapter number 3, Laws of Motion. Today we'll begin with Unit C, Linear Momentum and second law of motion, Newton's second law, okay, of motion. So in the last classes we have talked about forces in Unit A, different types of forces, contact and non-contact forces, different types of contact forces and different types of non-contact forces, isn't it? And in the last session we did Unit B, where we learnt about Newton's first law of motion and inertia. We were able to understand the concept of inertia, the two types of inertia, inertia of rest and inertia due to motion. We saw the examples as well, isn't it? And in the beginning of the chapter I said we have to learn about 4 laws here, Newton's 3 laws of motion and gravitational law. We have covered Newton's first law. Today we'll be doing Newton's second law. Before that we must understand the topic momentum, okay, and the word attached with it, linear. Now when we come to the meaning of linear, it means on a straight line path. Alright, now what is momentum? See, to understand momentum, let us first understand the concept of mass and velocity with respect to momentum. Momentum butnoko lagi, let us first understand what and how mass and velocity plays a role in momentum. For example, if a body is in motion, so when a body is in motion, body will have mass as well as this body will be having some velocity because it is in motion. Alright, now assume that you want to stop this body. Now if you want to stop this body, now let us take another here. In the first instant, let's say the body is a bus, and here, or I guess bus will be too big or a huge one, so I'll just take a thing. Let me take cycle, okay, and here I have a toy car. I guess these two examples will be much practical. So you are trying to stop the cycle which is in motion as well as a toy car which is in motion. Alright, now to stop them, what do you need? You need to apply some force. Is that okay? To stop this moving body, you must apply some force. Are you getting my point? Now, suppose say the mass of the cycle is 25 kilogram, whereas the mass of a toy car is suppose say 300 gram. Understand? So here you see that cycle will have more inertia as compared to the toy car. So you need to apply more force here on cycle to stop it as compared to this toy car. Is that okay? Now the other factor, see, now we discuss about mass, means more is the mass, you need more force to stop the body. Now the other factor is the velocity. Suppose say this cycle is moving very slowly. For example, say that it is moving 25 meter per second. So the speed is very slow here for cycle. Are you getting my point? But this toy car, which has a very small mass as compared to the cycle here, is moving with 1 meter per second. So means its velocity is very high. Means when you try to stop this toy car, it is going to hurt you because its velocity is more. But you can easily stop this cycle which has more mass. So here we see that the force that we require to stop the body which is in motion depends on mass and the velocity. Understand? So this force which is required to stop a body which is in motion is called momentum, or you can simply say momentum, denoted by somewhat letter called P, okay, denoted by P equals to mass into velocity. So momentum, or you can say linear momentum, is the force which is required to make the moving body having mass m and moving with a velocity v. So this is what we call linear momentum. Okay, is that understood? So mathematically, momentum is the product of, okay, momentum, okay, momentum is the product means multiplication, okay, of mass and velocity. What is it? Mass and velocity. So P equals to m into v. This is the mathematical relation to find momentum. All right, is it understood? Now let's see its unit. Now you know SI unit of mass is kilogram and the SI unit of velocity is meter per second, which I've already taught you, isn't it? So kilogram meter per second is the SI unit of momentum. Similarly, CGS unit of mass is grams and the CGS unit of velocity is centimeter per second. So we get the CGS unit of momentum or linear momentum is gram centimeter per second. This you can rewrite in this way also, kilogram, okay, per second, or gram centimeter per second. So this is in your exponential form or in the form of indices. All right. Okay, so this was your linear momentum. Are you getting my point? Now see, now let us try to understand this momentum if the velocity changes. So here we see that momentum is depending on mass and the velocity. If mass changes, your momentum also changes. If velocity changes, again your momentum change. So momentum depends on mass and velocity. Okay, and if mass and velocity both changes, your momentum will change. Are you getting my point? But let me take one example. Okay, there is a body of mass m. All right, body of mass m, okay, and to this I apply a force F for t seconds. What is this? This is t, small letter t second. So when I apply a force on a moving body, what happens? It's obviously its velocity is going to change. Mass will remain same, but its velocity is going to change. So if the velocity changes from u to v, so initially it was moving with initial velocity u. With the application of this force, okay, with the application of this force for t seconds, its velocity is now changing to v. So that is the final velocity. Are you getting my point? So there will be a change in momentum now. So initially, okay, initial momentum was mass into velocity, that is initial velocity, that is mu. Now the velocity has changed because I've applied some force here. So final momentum, okay, is going to be mass into velocity, but here the velocity will be now the changed one, that is v. All right, so there is a change in velocity now. So change in momentum, okay, change in momentum in t seconds, because the time for which I am applying the force is t. All right, so that is going to give me final momentum minus initial momentum. So here you see that m and m is common here, so I take it out, so I'll get v minus u. So m equals to v minus u. So from here I can calculate this was the change in momentum in t second. So now if I calculate change in momentum in 1 second, then I'll get m into v minus u by t. Are you getting my point? Did you understand here? Yes? Clear? Okay. But whenever you are learning about some physical quantities which is divided by time, then we say it is changing because it is like some time has been spent, isn't it? For example, velocity. What is velocity? Velocity is the change of speed, okay, with respect to time. Similarly, what is acceleration? The one that we studied in the earlier chapter. Acceleration is the change of what? Displacement. Sorry, change of sorry, I'm talking about displacement. What is displacement? Change of distance with respect to time, isn't it? So here also there is a change in momentum with respect to time. So this is what we call rate of change of momentum. So rate of change of momentum is mass into change in velocity divided by time. All right, but in the last chapter, okay, I gave you one relation, one equation of motion, that was v equals to u plus at. So from here I get v minus u. When I take this u on the left hand side, it gets minus equals to at, or v minus u, okay, when I bring this t, okay, on the denominator, okay, okay, wait for a while. Okay, okay, we were here. So when I take this t on the left hand side, since there is multiplication, so multiplication now becomes division, so I'll get a. So here from the equation of motion I get that v minus u by t banega a. So this part is a. So mass into I get acceleration. Are you getting my point? So I get a new relation now here, that is rate of, okay, change of momentum, okay, is m into a, that is mass into acceleration. Are you getting my point? So today we got two relation. One is linear momentum equals to mass into velocity, okay, whereas rate, okay, in change in momentum is mass into acceleration. So mass सँग acceleration multiply गरे भने you will get rate of change in momentum, whereas mass सँग velocity multiply गरे भने you will get linear momentum. Is that okay? Okay, now let us assume a ball. I have a tennis ball whose mass is m. Alright, so now what I do is I apply force F1 on this ball, so the ball starts to move with certain velocity v1. So in doing so, what happens? It has some acceleration produced on it, and let it be a1. So what I'm trying to say is that this force acting on this tennis ball makes the tennis ball move with certain velocity. But now you know that there are some external forces acting on the tennis ball, such as gravity, frictional force, which brings in the change in velocity, which in turn brings some acceleration or produces some acceleration on the tennis ball. Now I'm taking the same tennis ball. Now I'm applying force F2, where F2 is more than F1. So I'm applying a force which is much more as compared to the first one. Alright, so obviously body will now move with some other velocity, okay, which will be quite more than v1. Now again, due to some external conditions here, due to external force, that is frictional force and gravitational force, what happens? The change in velocity takes place, which leads to the change acceleration on the body. Let that be a2. Are you getting my point? So here you see that this change in acceleration depends on the body whose mass is same on the force that you are applying. So I can say that force here is playing a direct role to bring about a change in acceleration. So force is directly proportional to the acceleration produced on the body. So let this my equation 1. Are you getting my point? Now I will take the same tennis ball, okay, with mass m1, okay, and I'll take another ball which is a football whose mass is m2. Are you getting my point? So now I want to bring this body, move this body with same acceleration. So here what is happening? Acceleration is remaining same. So means that I have to apply some force in the tennis ball as well as on the football. So the forces that I'm applying here will be different because masses are different. So mass different bhakole gardakeri, if I want to bring about same acceleration on these two balls, I have to apply different forces here. So I see here that, okay, to produce same acceleration on the two different bodies having different masses, I require different forces. So force is here proportional to the mass to bring about same acceleration. So I get second equation, that is force is directly proportional to the mass. This is my second equation. Now what I do is I combine these two equations. So when I combine these two equations, I get that force is proportional to the product of mass and acceleration. Yo duitaलाई चाहिँ मैले के गर्दै combine गर्दै. Are you getting my point? So I combined the equation 1 and 2 and I am getting force is proportional to m into a. Now I will convert this proportionality sign. This sign is called proportionality sign. So when I drop this proportionality sign into equal to sign, then I have to add a constant. So here I add a constant k, so I'll get f is equals to kma. So k is a proportionality constant. Are you getting my point? Now, so k is a constant here. Now if I assume, okay, the force to be unit, acting on a unit mass so as to produce a unit acceleration, then I get 1 equals to k into 1 into 1, where I get k equals to 1. So if this is my equation number 3, now replacing the value of k equals to 1 in equation 2, I get kf is equals to 1 into m into a, or f equals to ma. So this is my equation. Alright, so in the earlier beginning of the video, we saw P is equals to momentum equals to mass into velocity. Then we get rate of change of velocity is equals to m into a. So now here we are getting two equations which looks quite similar. That is, rate of change of momentum is equals to ma. Now here we are getting f equals to ma. So these two gives us a new law called Newton's second law of motion, where it says that rate of change of momentum is directly proportional to the force that you are applying on the body, okay, and it takes place, and this change in momentum takes place in the direction in which the force is applied. So rate of change of momentum, okay, rate of change of momentum is directly proportional to the force that you are applying on the body, and this change in momentum takes place in the direction in which the force is applied. So this is my Newton's second law. Are you getting my point? Okay, so we got Newton's second law. Now I will tell you one more thing here. In the Newton's first law, okay, in the Newton's first law, okay, first law of Newton of motion, or we can say in the first law of motion, we just learned about the qualitative nature of force. Qualitative nature of force. Force le ke garna sakcha? What force can do? Force can either bring a body which is in rest into motion, or a body which is in motion to rest. So that was what Newton's first law said, isn't it? It said that a body which is in motion will remain in motion, and a body which is in rest will remain in rest unless an external force is acting on it, isn't it? So Newton's first law was just saying about the quality or qualitative nature of force. Force is the key गर्न सक्छ. What can force do? Understand? But Newton's second law is telling about Newton's second law of motion tells us about quantitative nature of force. Quantitative nature. Okay, means to make that body move, a body which is in rest, to move it into motion, to set it in motion, or a body which is in motion, to bring this into rest, how much force is needed? That is given by F is equals to ma. So the product of mass and acceleration will give you the force that is required to set a body which is in rest into motion, or to set a body which is in motion into rest. So quantity, kati force, how much force. Okay, but here in the Newton's first law, what force can do, but how much force is required to bring that change is given by Newton's second law. Are you getting my point? So this is the two laws of motion that we have learned till now. Now we will learn, we got the definition. Now see the exact definition of force here. Okay, the force is the product of mass and acceleration. Now we'll see the units of force. All right, so units of force. So we got force equals to m into a. So what is the SI unit of mass? Kilogram. What is the SI unit of acceleration? Meter per second square. So kilogram meter per second square is the SI unit of force. But in place of this we use Newton. Okay, so Newton abbreviated by the capital letter N. So Newton is the SI unit of force, where we saw that 1 Newton equals to 1 kilogram into 1 meter per second square. So from here we can define what is 1 Newton. So 1 Newton is the force which is acted on a mass of 1 kilogram so as to produce an acceleration of 1 meter per second square. All right. Now in the CGS unit, it is dyne. CGS unit of force. CGS unit of force, okay, is dyne. Now what is dyne? You know, F is equals to ma. So here we are saying that dyne is the unit of force in the CGS system. In the CGS system, unit of mass is gram. Okay, and the CGS unit of acceleration is centimeter per second square. So if I write 1 dyne, so 1 dyne equals to 1 gram into 1 centimeter per second square. So define 1 dyne. So 1 dyne is the force, okay, which is acted on a mass of 1 gram. Okay, mass of 1 gram, so that the acceleration produced on it is 1 centimeter per second square. All right, so this is your SI and CGS unit of force. In the SI unit, SI system, the unit of force is Newton, and in the CGS it is dyne. Now let us derive the relation between them. 1 Newton भनेको चाहिँ how many dyne? Okay, so let's do now. Now you know that 1 Newton is nothing but 1 kilogram into 1 meter per second square. So here I get 1 kg means how many grams? It is 1000 gram into 1 meter means how many centimeter? 100 centimeter per second. So I get 1000, okay, into 100 will give me 1 lakh gram, okay, centimeter per second square, which means I can write this in exponential form. 10 to the power 5 gram centimeter per second square is what? Dyne. So I get the relation 1 Newton equals to 10 to the power 5 dyne. So this is the relation of SI unit of force with CGS unit of force. Alright, so sometimes you may get a question, derive a relation between SI unit and CGS unit of force. So this would be your solution. Alright, So this is it for today's session. Okay.